If you divide a square into three parts, but one part is bigger than the others, is it divided into thirds?
Welcome to Level 4. In this level, we will explore fractions, and today's math quest has us looking at thirds? I know we've talked about other fractions before, but we need to investigate further before attempting the math quest. Let's dive in. Imagine you and a friend have a cookie to share. How could you split it so that both of you get a fair share? If you cut it into two equal pieces, what do we call each piece? Wait, two more friends want to share the cookie too. Now you need to cut it into 4 pieces. How much of the cookie does each person get? This is where fractions come in. Fractions help us divide things into equal parts. Let's review what we know so far and see if it can help us solve our quest. Here and in your guided notes, we have 4 examples that have been broken apart into 2 pieces. Do you remember what we call the pieces if an object has been split into 2? That's right. Each piece is half of the whole shape, so we call these fraction parts a half. Is that all we need to refer to these pieces as halves? Think about the cookie we just saw. How can you split it so you and your friend each get an equal half? Now look at these shapes. Can you tell which ones are split into 2 halves? Great! Shape A and shape C are both correctly split into halves. Take a closer look at shapes B and D. In both of these examples, one piece is bigger than the other. We can really tell the difference if we lay the 2 pieces on top of each other. The piece on the bottom is bigger, and the piece on the top is smaller. So we remember that when an object is split into 2 equal pieces, they are called halves. But what about if it's 4 pieces? Do you remember what those are called? Exactly. 4 equal pieces are called fourths. Let's look at some examples. Look at the next set of shapes in your guided notes. Which of these shapes is broken apart into fourths? There are more pieces to look at in these examples, so I think it's going to be helpful if we lay the pieces on top of each other to check if they are the exact same size. In example A, we can see that the piece on the right is way bigger than the 3 pieces to its left. So these are definitely not equal shares. What about example B? All 4 pieces look like they're the same size. If we stack the pieces, they would match up perfectly. So example B is correctly cut into fourths. Now we have examples C and D. They look similar to each other, but only one of them shows equal shares. Which one has 4 pieces that are exactly the same size? Watch me cut them apart to check. What did you notice? That's it. Example C is the correct shape. The pieces in example D are 3 different sizes, but example C's pieces all match up. Great work! We've reviewed halves, which are made of 2 equal pieces, and fourths, which are made of 4 equal pieces. If we cut a shape into thirds, how many pieces do you think it would be? Similar to how 4 is part of the word fourths, when there are 3 equal parts, the pieces are called thirds. Let's split up some shapes into thirds. We're starting out with this square that we need to turn into thirds. Where could we draw lines to make this into three pieces? Hmm. When we did halves and fourths, we sometimes started by drawing a line down the middle of the shape. If we do that with our shape, we have two pieces. Now, where can I draw another line to make this into three pieces? Here? No, that's not it. We have one big piece and two smaller pieces. What if we split it in half going across the middle? That doesn't work either. Although we did create a nice set of fourths, I don't think we can start by drawing down the middle. What else could we try? We have a hint. Follow along with me in your guided notes. These dotted lines can help us practice breaking these apart. This first line is not down the middle, like with halves. It's a little bit to the left of that line. And the other line is just slightly to the right of the center. Interesting. This gives us three equal pieces, thirds. The next one is very similar, but the lines cut across the shape instead of down. They nicely cut this square into thirds. The last one is quite different. What do the lines inside of this circle remind me of? The lines look like the letter Y and split this circle into three triangles that are the exact same size. Now that we've had some practice splitting shapes into thirds, let's check some additional examples to decide if they're cut into thirds. Just like with the other fractions, we're going to look at four shapes and see if they're broken into equal parts. Can you tell which two shapes are correctly split into thirds? Well, shape B is the same as the square we drew lines on from top to bottom into thirds. So shape B is definitely split into equal parts. What about shape C here? I think we can tell that one of the three pieces is way bigger than the other two, so it's not shape C. We're down to shape A and shape D, which are both triangles that were made into three pieces. Watch me cut these apart and stack them to check if they're the same. Which shape do you think is cut into thirds? That's right. It's shape D. It was cut into triangles like the circle we split up earlier. Shape A's pieces are different sizes. We've had some practice with thirds, and I think we're ready for our math quest. Actually, I know we're ready because we already discovered the answer when exploring thirds. So if you divide a square into three parts, but one part is bigger than the others, is it divided into thirds? No. When working with any fraction, we always have to break apart the shape into equal shares. Write our final answer on your math quest while I input our answer. Amazing work today. Those thirds were definitely more challenging to break apart than the halves and fourths, but we persisted and solved the math quest. Remember, every problem has a solution, and we've got the skills to solve it. See you next time.